Hello everyone. How are you? I hope everyone is fine. Uh, yeah, welcome to the stream. I hope everything is clear. Let me just check the chat boxes. Yeah. Good afternoon, everyone. Just give me like a wave if everything is fine. The sound is fine. You can hear me. You can see me, and there's no lag and all that. So yeah, just give me a shout out. Right? Okay. First of all, thank you for submitting. Most of you, thank you so much for submitting your assignments on time. And yeah, okay. And yeah, there were some. Most people submitted on time. Most people did good also. And there were a few really good assignments, really well done assignments, and there were few which needs a lot of improvement. So we will take a look at some of the assignments. Of course we can't take a look at all of them, but we will I've kind of selected a few which were good. So yeah, right. Okay. So let's do one thing. Let's start off. Do you want me to start off with checking out some of the assignments? Yeah. So I think you're saying yes. So we'll go. We'll go forward. Okay. Okay. Let me just change this thing. Yeah. Okay. So I hope you can see my Excel sheet. There are a few people who have not submitted, right? So what I will do is I will put this Excel sheet up, and what you can do is you can check if you've not submitted. Most of them I've gone through the submission folder, and I've also gone through the OneNote assignment lists. Okay, so if your assignment was anywhere in these two places, I've marked it accordingly. And just go ahead and see what you have done and what you have, if you have missed anything. Ace, you have not submitted any of them, right? Amir, Anirudh, I'm sure there are some fairly justifiable reasons why you couldn't complete, but try to finish. If you have some issues, if some people are facing issues with submissions because of some problem at home or something, please send me a mail, rather than just not submitting the assignment just like that, or missing the deadline and not submitting the assignments. So first, send me a mail. I'll So some of them I've given some extra time, some of them I've given like time till the end of the semester also to submit. Like I think Devaditya, I think he could submit only one of them, because of some issues in his home. I had given him extra time to submit. Okay, so like that only I can kind of give you some additional time if needed, but I need to know the reasons why you would not be able to complete it during the deadline time, right? Okay, so let's just take a look at this Excel sheet. This is like who submitted and what they submitted, and the bold ones that I've put here, those were interesting assignments, and I really liked these assignments, and they primarily captured what I intended when I gave you this assignment, right? So that's why these were bold. Uh, Chaitanya, I think there was some problem in one of your submissions. Could you please resubmit again? I think there's some error in the PDF file or something like that. Okay. Uh, right. The way I checked for late submissions is that I have given, if you submitted on or before 17th, then I have not considered late submissions. But if you've submitted beyond after that, then I have considered the submissions as late submission. In these two assignments, I will not reduce marks. Okay, because this is the first time that you're doing it. So I will not reduce marks for late submissions in these two assignments. But going forward, please ensure that once you have pasted your, let me just check the chat boxes if everybody is responding. Give me a second. Yeah. Right, Chaitanya. Okay. Mail me right away. Daniel, you can't just just submit just like that. Anushka, if you have submitted, I could not find it. Okay, just go ahead and recheck, please, and re-upload your assignment. So this is the first time, and probably this is the last time, unless you have some genuine issues with submissions. Don't do late submissions. So Anushka and everybody else who were not able to submit, you can immediately submit before tomorrow. Okay. Yeah, Anushka, you do it. You resubmit again. Okay, before tomorrow you do. Okay, right. Okay, so this was these were the whole things. There was many. Meghna, for example, she did some very interesting projects. For her disassembly, she did handheld gaming console, and for the product concept, she did like a vegetable storage. Although the vegetable storage was a little okay, but yeah. Some of them were quite interesting, like Fahim's. I really liked Fahim's overall submission. The pedestal fan. The most interesting part of the thing was he gave like some behind the scenes photographs, which are very interesting to see how he set it up and how he took the whole thing. And you guys can also go ahead and see. I think he's made like a WordPress. WordPress thing. Okay. Sachin, do not mail. Okay, nobody, please don't send me mails because it gets lost. Yeah, every day, all faculty members every day they get around 50 to 60 mails, and it becomes very difficult to sort through them and arrange it from our own side. And that's a time that I don't want to spend. So you put it in your folder. Everybody put your assignments in the folders or the OneNote file, depending on how you are submitting. Okay. So Sachin, don't mail. Right. So let's take a look at some of these interesting ones. Okay. Anshida. Okay. Wait. So what I should do is I should go here. I hope you can see. And let's take a look at the product concept that Anshida submitted. Okay, so this one, go away. Are? So there's been some problems with Adobe CC in my computer. So yeah, anyway, so she made this. She chose this one kind of technology, which is electroluminescent or mechanoluminescent technology. Okay, yeah, go away, go this way, and let me do this. You see this? Okay, it looks like I will not be able to open it and show it to you unless, just give me a second. Right. So it's a kind of material which glows when mechanical strain is applied to it, right? Okay, and they have a different kind of use case presented, but what she did was she made like these gloves for for people with who do sign languages, for them to make it easily interpretable. Okay, if it's making sense. So it was quite interesting to see the use case. However, I would have been more happier if Anshida was able to render it properly. By that I mean make it, present it in a much nicer way. So just like one sketch is not good enough. Okay, so anyway, it was the reason that I like this was it's an interesting, material concept, and it was an interesting use case which was found. I think somebody else also did this, and yeah, okay. So let me check another one. Okay, so Arjun did one very interesting one. I hope you guys are seeing, and I hope there's, so yeah, keep the chat boxes alive if you have any questions or anything. So Arjun did one very interesting one with materials. I mean, okay, so it was like a, so this is like a scooter, but the idea is that it has this kind of a meta material which you can compress and you know you could transport it very easily. Yeah. Give me a second again, guys. Right. Uh, yeah. Till then it opens. Right. So the idea is that this metamaterials are a type of materials which are basically use some engineering principle and at a micro scale, and these properties, these principles kind of change the properties of the material as a at the macro scale. At the macro scale, it behaves as a material with certain specific special properties, but at the smaller scale these can be set as a unit of this material at a smaller scale, can be said to be made out of typical materials, right? But the construction is quite unique. You can see an example over here. The idea is that what Arjun did was he took this kind of a meta material idea where you have two surfaces which are connected by these flexible rods, and when you apply a kind of a point force on top of one of them, so these rods kind of bend and the two plates collapse together. I think this kind of a toy also exists. Okay, now the thing is, this is at a micro scale. Okay, and the idea that Arjun did was he kind of ran with the idea and he made like this concept of a scooter which would be made with these metamaterial blocks and at a micro scale. But at a larger scale, the way it behaves is that when you press it, it shrinks down. Although this is in the realm of science fiction, I mean it will be very difficult to say whether this will work in reality. It probably will not. Okay, but the idea is that you as a designer should not be scared to push for these concepts which probably do not seem feasible at the starting. Okay, what will happen is that, I hope you can see me. Yeah, I hope you can see me. Okay, so what will happen is that if you are able to push these concepts, right? So if that is not possible, then something just below it, something slightly not uh, as science fictiony, can definitely be possible, and more use cases can probably be derived from that. Okay, so if you understand what so so it's something like aim for the stars, and you will land at the treetops, something like that. Okay, so basically here the concept is pretty far fetched, but by thinking this now, if somebody wants to work on this, he'll probably end up at a position which is much better than what they have right now. Okay, so that's why I kind of like this idea. Let's take a look at others assignment. Where's my Excel sheet? Okay. Yeah, this one, Cyril's assignment, I really liked. He made like a bicycle lock with ceramic embedded aluminium foam. Okay. And I'll not go through all of the assignments again. So Cyril's assignment, in his assignment, what he did was he took this kind of again a meta material, which is like a matrix of aluminium foam and ceramic. So ceramic balls are embedded inside an aluminium foam lattice. Okay, you can call it lattice, and it's still in development. It is still in research, but the property of this is that it's very difficult to cut this material using traditional tools like a hacksaw blade or a saw blade, because once you start cutting, once the blade start hitting the ceramic balls, they these things vibrate internally and kind of try to chip away at the cutting tool. Okay, so that's why it generally does not allow to cut. So that's a very interesting property which was seen, and the way he really went into how it was manufactured and all that, he found out these information. Although I'm 100% sure that 99% of you have copy pasted most of these text materials. Okay, now since this is not going out into a public domain, it's okay, but yeah, I mean, don't try to copy paste, but yeah, whatever, just to explain what the material is, it's okay, I will consider it. So the way what he did was he made like a bicycle lock with this. Now the reason that I liked this project, this assignment, was it's, first of all, it obviously borrows from the technology, it meets all the requirements of the assignment, but then it is presented in a manner which Cyril can probably use these images for his in his portfolios. Okay, so he can put it up on Behance, or he can put it up in his portfolio and all that. Okay, so he's done some interesting work, and I can see that he already has the skills for the design rendering and all that. So yeah, that's good. That's always that will always be a strength for going forward. Okay. Okay, so let's take a look at who else. Okay, I'll not show all of them. Okay, Madhav, I could not open one of your this thing. Right. Okay, let's see. Yeah, let's see Fahim's assignment, both the assignments. Okay. Well, so Fahim, Fayaz, and I think that's Ronak. Ronak, Fahim, and Fayaz, please don't use like your first name, because all three of you have the same first name. It becomes confusing for me. So better use Fahim, Ronak, and Fayaz. So that way it's easier. I think this one is Fahim. Okay, let me just see. No, this is Ronak. Well. Yeah, so this is Fahim's concept, and he's used like a uh, again, it is a different type of metamaterial which when it is exposed to light, I think it changes its shape. Okay, and he or I think there are other things also here. So what he designed out of this is like he designed like a diaper, and the idea is that when there is pee in the diaper, when it is wet, it glows, and there's a clear indication that there is some the diaper needs to be changed. Okay, so that was his idea. Again, I'm not too happy with the presentation overall, but yeah, I mean, it's okay. Okay, I like the idea. Okay, let's uh, Yeah. So I will show you Fahim's knockdown assignment. So he did like he presented it in a WordPress, this thing, and you can see. So what I saw in most of your assignments was that most of you took products which had a lot of plastic parts in it, and the problem you naturally ran into the same problem. Everything is made out of injection molding on, right? So injection molding this, injection molding that, although that's not true. There are a lot of other manufacturing processes there, but right now, since we are not discussing that, and I said that only injection molding you can consider that, right? So a lot of people kind of gave me just injection molded parts and all that. So that was a little weird. That's a loss of opportunity, right? So yeah, anyway, so here you can see the pictures are nice, they are well lit, you can understand the form of the product, and you can understand. So he's put what is the materials, what is the process, and what properties. Simple, straightforward, and it's good. Okay, so now the reason that I like this assignment more is because at the end of it, I think he has put like a behind the scenes. Okay, and in the behind the scenes he's put like a video and all of these pictures of how he did it. Okay, so this was very interesting for me to see. It's of course going a little beyond the requirement of the assignment, but it's good to see that this was done, right? This is how it was done. It's very interesting. I can show this to other students in the future. This is how you should do. Okay, so that way, fine, thank you for this. It will be a resource for me. Okay, so let's so who else do I want to see? Yeah, Sanika, this one I really want to see. This is one of Sanika's assignments were one of the best ones. I don't know if Sanika is there in the chat. If she's there, just do a wave, do a hi, do something. Okay. Let me just answer your queries first. Anushka, don't panic. I gave you time till tomorrow. Relax, you submit till tomorrow. If you can't submit till day after, it's okay. Okay. Anushka, if you, I'll recheck your files. Okay. Madhav, one of these, on the left hand side, on the right hand side, this column is the product concept, and on the right hand side, this is the product disassembly. So you check this Excel sheet and you upload the right assignment. Okay, Sanika is here. Let's just see Sanika's work. Okay, and where is Sanika? Here is Sanika. Okay, this was so lovely. This was so nice to see, no? So first of all, what she disassembled was this. It's an air gun. It's an old air gun, and I particularly liked it because this brought in some very nostalgic memories. I used to have one, and I don't know where it is now. But yeah, it's good to see this is how it's done, right? It's a very simple GIF, but the work that she did. Okay, I hate Adobe. Let me just put it on record here right now. I hate Adobe because when I want to work, it does not work. Okay. Okay, it doesn't work. So yeah. So what she did was she took really nice photographs. I don't know how she got this, but the details within the parts and see the joineries, no, you can see how this was made. So this part is different from this part, and this was braced together, or yeah. So this was braced together. These two parts were braced together. You can see those details, right? So those details are what counts for this. And then she really went into details of what exactly are these parts for, and that the functional aspect, although it was not needed, but it's really good to see, the knowledge of the product. And beyond that, I think she went really in detail into, let's see the Adobe XD one. I don't know if this will work. Adobe is crashing on me since morning. Okay, I hope you guys can see. Okay, just give me a, yeah. uh, Anirudh, yeah, man. I mean, I don't know. Yeah. Okay, you submit then. I somehow try to submit tomorrow. I don't know what Tejas is saying. Tejas, Chaitanya, handshake, Pankaj sir. Okay. uh, Web of, you don't need to submit GIFs, okay? Web of, you don't need to submit GIFs and all that. That's not the requirement. I mean, if you have submitted, it's a good thing, but yeah. Okay, this is not running. Ah, anyway, Sanika's things are there on the folder, and you guys, I will urge you to go and look at what she's done. And even the product design assignment was very interesting. Although I felt a little weird. I mean, I didn't very clearly understand why this was chosen. But again, yeah, just give me a second. But it was interesting. I mean, it's a very designerly approach. So just because you are learning a very technical subject doesn't mean that you have to keep all your designer instincts aside. Okay, so what she's gone through a proper process of, ideating what she wants to design. Okay, so the idea is that the material she's chosen is nitinol, which is like a shape memory alloy. Okay, it's a alloy of nickel and titanium. And yeah, and if you can basically lock it in a certain shape and then modify it, and if you heat it, then it will come back to that shape. So that's the idea of nitinol. And she's designed this kind of a vase, in fact a collection of vase. It's a vase or vase, one of them. Okay, so she's designed this and it looks very interesting. And again, you can see that these pictures, you can use it in your portfolio and all that. So always work towards that. Yeah, okay, yeah, Sanika, good job overall. Yeah, okay, close our tabs. Fine, let me just transition to this. Okay, yeah, so that was the assignment, and I hope you guys saw. Yeah, thank you Chaitanya for re-uploading. I think this one is better. So thank you Chaitanya for re-uploading the files, and for everyone else who has not submitted, I am giving you still 1 day's time till tomorrow to submit it. Okay, although those who will submit it tomorrow, I will not grade them in full marks, but I'll not give a 0. Okay, for the late submission guys, although I've marked late submission, but I will not deduct marks for late submission for just these 2 assignments. Going forward, it is going to be there. So remember, when you paste your files in the folder, number 1, it should work. Okay, if there's an error, then I will consider it not submitted from next time onwards. Okay, if there's an error in the file, so you should make it extra sure that it's a working file which you have submitted. The second thing you have to ensure is that once you've pasted the file in the folder, you don't overwrite it. Okay, you should ensure that the modified date of modification remains the same in that folder. That's how I check when you have submitted. So if you overwrite it, it will get a new date and you have lost that. Okay. Okay. So are you guys okay with the assignments? So I think we'll do it like this only. Going future, if you want some specific if you want, yeah, Madhav, you re-upload. Okay. So if you want some specific inputs uh, on the assignments, so I think what you can do is in your OneNote documentation, no, there are two places where you can put in questions. One is like a doubt space for doubts. Okay, so you can put in there, and the other is there is a space in each one of your folders within the assignments, pages. You can just type in your questions, and when I go through them, I will answer. I'll put some answers in there. Okay. And if it's relevant to the rest of the class, then I'll put it there. Okay. So yeah, that's it. Should we start with the main class? I think we should. We are already half an hour down. So what we will discuss today is we'll continue the machining part. Okay. And so let me just bring up the air on earth. Yeah. So we will continue the machining part. We already discussed this slide. Okay. Here we were discussing about the design of the drill bit. Okay. But we'll go forward. There are some more slides which we skipped last time because of lack of time. So let's recap that. I hope some of you went through it, but we'll just discuss it over here. I'll add some points to the whole thing. Okay. Right. Okay. Where's my? Can you see my big cursor? I hope you can see my big cursor. Okay. Yeah. Right. So yeah. So when we are designing for machining, there are a few things you should consider. So machining is, since it's a material removal process, okay, you have to ensure that the job, that the working piece from which you are removing the material, it's held together properly. So one of the main reasons for failure in machining is vibration in the job. So if there's any reason because of the clamping of the workpiece, because of the clamping of the workpiece, there may be vibrations, and this may damage the tool and the machining would fail. Okay. So it's always so vibrations is one of the main reasons for not being able to do certain things in machining. Okay. Direct machining. So here we are taking a look at some of these things. So like for example, the first image that you see over here, so it says no, yes, right? So this basically says you shouldn't do this in machining, right? So the idea is that it's very difficult for to start cutting at an when it's an inclined surface. Okay. So when you are drilling on it, or when you are milling, let's say, or drilling, then if the surface on which you have to start working is inclined, what will happen is that when the cutting tool comes down, there will be a significant amount of force this way exerted by the surface of this body. Okay. Because of which the cutting cannot happen properly, and the chances are that the tool will either vibrate, or there will be some undue stresses in the tool and it will break. Okay. So you should never have like a slanted surface where you are starting the machining. Okay. So this you should not do. Rather than this, it's a better idea to modify the design and have something like this. Remember, in all of these recommendations, this is not like never do this, it's impossible. It's not like it's impossible, it's certainly possible, but so this adds a certain level of complexity to the machining process, which increases the costs of the whole thing. Okay. So as you can see in this one, uh, uh, they say that don't do this, right? So the reason he's saying, they're saying something like this is because when this is a cavity, so once the drilling starts, the bit reaches a point where there's no cut, nothing to cut on this side, but there is some cutting action going on the other side, okay, which again puts stresses on the on a certain direction, right, tangentially to the, or rather perpendicular to the axis of the rotation of the tool, okay. So these forces kind of may bend the tool slightly and put undue pressure on the tool. So rather than that, it is always a good idea to minimize such spaces where the tool does not have a significant portion to cut, okay. Now one of the so this is a milling, this three images are examples of milling. Let's say there is like a, if you want to cut a square block, it is certainly possible. It's square, that means it's 90 degree as close to 90 degree as possible, right? Nothing can be perfectly 90 degree because 90 degree is a mathematical concept, but in the real world there'll always be some amount of error and some amount of surface undulation which makes it slightly up or down 90 degrees, okay. So it's impossible to get a perfect 90 degree in the real world, okay. uh, right, so you can have like a square block made, okay, but let's say you want to fit it into a cavity which is square, right? So you have to cut a square cavity. It is very, very difficult to cut a square cavity with traditional machining processes, the ones that we study, okay. It is however possible through something like electrode discharge machining, but let's talk about traditional ones. It's very difficult to cut in that. So why this is there? Because let's say you want to cut this kind of a shape, the way you would cut it is you would use an end mill cutter, right? So you would use a cutter which cuts from the sides and cuts from the base, and that will, when that cuts, the minimum radius that you can cut, right, is the radius of the tool, okay. So here the fillets, the corners will never be sharp. It will always have the minimum radius, which is the radius of the tool, okay. But if there's a radius like this, a square block, when you want to fit it into this, it will never fit, right? So because this corner will interfere. So this is one of the tricks that people use, like to provide a relief hole. So always when there are two things fitting at a with very low tolerances, it's a good idea to think about where and how you can provide reliefs, okay. So this is an idea of a relief. I don't want you to just take away this shape which you should do, but the idea that you need reliefs when things need to be fitted together, okay. Besides this, in this one we have some of the things that you should consider when you are thinking about drilling. First and foremost, do we really need to drill is the first question. Do we really need to mill? Do we really need to drill? Or do we really need to go into lathe? Try to avoid any processes as possible. The best product that can be designed or manufactured is the one where no machining, or rather no manufacturing process are needed. So directly you take raw material and that itself is the product. That's the best product, okay. But that's like a very, very idealistic scenario, naturally. So you have to minimize the machining processes, right? So first you ask, do we really need to drill? If yes, use like standard drill sizes. There are always yeah, thank you so much for everybody who's re-uploaded. That's okay. Yeah, so I was saying, so always use standard drill bit sizes. And so there are two things here, two topics or two ideas that you should note. One is a through hole and one is a blind hole. A through hole is something like this. It goes through and through the part, okay. A blind hole, that means it ends within the part. So you drill and it ends somewhere before the part, before the other surface is achieved. So that's a blind hole. And uh, generally you should avoid design features which would need very fine tools, okay, unless it's something that's absolutely necessary. You should avoid tools which are very thin and very fine, because in when the product goes into mass production, chances are these small tools are the ones which will break more often, okay, because naturally they are weak, and there are chances of putting undue forces in them more than, they are not resistant to more forces. Yeah, okay. And remember that in a product, if there are multiple holes, or for that matter multiple screws or multiple ways of joining, okay, it is always going to increase costs. And uh, in fact it increases costs fairly exponentially. So you have like 5 holes of 5 mm, okay, it's cheap to do. You have one hole of 1 mm to, let's say, the fifth hole at 10 mm, right? So this will need much more, this will be much more costly to do. Why? Because in mass production you would have to change the tools, so there will be some time that will go in changing the tool, okay. If it's done manually, then there's cost of labor, so the time involved is definitely there. Then there's cost of labor and so on and so forth. If it's done in a CNC machine, for let's say, then there'll be some time that is going in the machine when it's changing the tool heads and all that, okay. So it will always cost more. And again, there's this one kind of thumb rule. So these are just thumb rules, right? So for you to be able to decide on designing something nicely, if there is like a significant change in direction, the costs of more. So by that, what do I mean by that? So let's say there's a square, let's say there's this cylindrical object, okay, and there are some details that you want to machine, right? And the way you are doing it is, first you are clamping in the lathe machine and it's turning, and you are doing some features like this, and maybe like the facing operations and all that, okay. So let's say now what you want to do is you want to have a hole on this end, okay. What you would do is you remove this, you change its direction, you put it back in, and then you drill, right? It's impossible to drill from the chuck side of the lathe, right? So this kind of changes in direction of in the job, right? It is always going to cost you more time and hence more money and so on, right? So and also remember that the every time something is changed from when it is clamped, no, it imparts a certain degree of inaccuracy in the whole process, right? So you have, let's say you have turned this whole thing into a perfect cylinder and you faced this and it's done, right? Now you have to make a hole on one of the other side, so you turn it around, you make a hole. Now the idea is that the next operation is that you have to turn it back again, okay, and make like a bigger hole from this end that connects this smaller hole here, let's say, okay. It's just an example. So as soon as you change the direction, the process, there's some amount of movement that has happened, right? So there's some amount, so maybe it's clamped like this, maybe it's clamped like this, maybe it's shifted from its axis. So there's some amount of inaccuracy as these changes happen, okay. So it's always a good idea to first finish a certain manufacturing or machining process and then go into the other one to reduce such inaccuracies and reduce cost because of these directional changes, okay. Okay, right. Okay, so just like that, here is a small list of things that you can consider when you are designing different parts, okay. So first let's just run through them, okay. So first one, it's fairly self-explanatory, most of these images, okay, and but still we can discuss some of them. Like the first one, look at this one. So you have one one, both are these threaded holes. Okay, so they are threads, internal threads in this. So one is like this, fully flat, and one is like this, right? Which one is possible? Which one, or rather, which one is more accurately represents what will happen in reality? This one, the second one, right? It's not like do this and do this and don't do this, right? So the why this will be possible is that mostly the way you would make this is you would first drill a hole, okay, slightly smaller than the actual thread diameter, and then you would tap it. So tapping is the process of putting threads, internal threads or external threads. There's a certain tool which cuts in the threads, and that's called a tap. Okay, so you use that to create these internal holes. Okay, and when you have drilled the first hole, the shape of the drill is the shape of the hole, right? So you never get something which is like this. So don't design it to be like this. So when you are making it in your CAD models and all that, so never make holes which are like this. Try to use the inbuilt tools for making holes. Okay, here, right, the second one is that you should try to use standard dimensions. So as I said, drill bits come in standard hole sizes. For larger holes, it's possible to be slightly here and there with the dimensions, but for smaller general holes where you want to put a bolt or you want to make a thread, something like that, no, you always use standard hole sizes. Now I'll not give you what are the standard hole sizes. Now this is something that you have to search and find out. Here it's given in inches. Yeah, right, don't do inches, I mean do a metric system. There are standard holes in metric sizes, and there are some standard so these follow a standard. So there's standard across these holes and across the fasteners also, right? So for example, let's take fasteners. Okay, so machine screws. So machine screws come in the standard format like M1, M2, M3, M4, something like that. Okay, it goes on to whatever. So this M3, let's say, is a specific dimension nut, okay, with a machine thread. And to fit this, this will fit well in a standard, let's say 3 mm hole, okay, and it will be a loose fit, and it will go in nicely. So when you are designing, if let's say you made something like 3.75 or 5 mm or 4 mm or something like that, right, non-standard, let's say, where you want to fit an M3 bolt, it may have some problems. Okay, so try to use standard dimension fasteners and standard dimension holes. Okay, right. So here you see one where there is a cavity. So this is like a cross section which is shown, and there is a cavity internally which is cut. Now, is this possible? The first one is certainly not possible, because you will not have a tool which can kind of go in and bend and cut like this, right? Even a milling machine, it's very difficult to cut. The second one which is in the bottom, it is possible. Like you could have like a first pass done by an end mill which cuts a small groove here, and then from the edge of the piece, cutter, which is a milling cutter, which is something of this shape, like a T shape, can cut the path, okay, in this cross section. So it's possible, but think about the cost. So unless it's absolutely essential to do this, and there's some major considerations in aesthetics and usability and all of that, don't do this. So you rather use this kind of a method where you have like this part made out of two pieces. One is an L, which is small groove, and then another plate is fitted. Okay, same thing here. Okay, let's see the next one. So naturally, very long and narrow holes are not possible. Okay, unless you go for very specific special manufacturing processes. Typically it should not be done, because as the tool gets longer, the tool tip, it vibrates a lot. Okay, so it spins. When it spins, at a high speed, it vibrates, and so there's no accuracy when it cuts. Okay, right. So yeah, so as I said about the internal radii, this kind of thing is not possible. You should always try to have good radii, at least the kind which is standard. So even the internal radii are standard. So these standards are of course from directly taken from the standard dimension of tools. Okay. Excuse me. Right. Uh, okay, so when you are machining, be very wary of thin sections or thin walls, because when you are machining such kind of thin wall sections, chances are that the material will get caught away when the milling or drilling bit is kind of going through it. It will tear. Okay, so because of that, so always avoid thin walls. And also, if you have something like this, let's say, and then you want to do some machining operations on the top part, see this C part, it starts behaving like a spring. Okay, so there'll be huge amount of vibrations on this part, and you'll never get like an accurate cut on the top surface. Okay, so to avoid that, it's better to have uniform thicknesses all around the part. But this is a very idealistic scenario. Don't aim for this always. You will definitely have thickness variations in parts, but you have to be very considerate about the places where it's low thickness. Okay, right. So this one, as I said, inclined surfaces, it's a bad idea to drill on inclined surfaces. So always ensure that if there is a drilling operation that's to be done, it's done on a flat surface. Okay. Right. So some of these are fairly, seem common sense, but they are not very common, as my teacher used to always say. Common sense is not very common, he used to say. Okay. Right. So let's take a look at this one. So for example, the hole here is quite close to the surface. So when you are drilling, chances are that the drill bit will get stuck on the surfaces here. So that will be a problem, right? So it's always a good idea to put the holes away from the corners. Remember that when you are when you are modeling, it's very difficult to kind of understand, how the machining will be done unless you're really putting your thought to it. So one of the most common mistakes that is done is that when you are making larger parts, people do not consider that the tool is fixed onto something which is much larger in size. So when you are doing milling, if you have seen the milling machine, then the place where you fit the tool, that thing is fairly large. So, and if you have to machine a surface like this, and at this point there'll always be some amount of interference may happen. So this will definitely be not possible. Okay, you could do it from the other side, but yeah, like this it's not possible. So rather than that, if you have some kind of process that will happen like this, it's always a good idea to shift it to a better location where it accommodates parts of the machine. Okay. Right, so this is what I said. When you have long thin sections, it will tend to vibrate and cause damages to the tool. Right. Again, something similar here. The tool is fairly long, and because of this length, there is some vibration which happens, and you may not get the right kind of cuts and all that. Okay, naturally internally bent holes are not possible. If you are doing something like this, then yeah, well, so it's always so technically what you may need to have some features like this in your design, right? For example, in plastic die designs, there are these fluid channels which are there, which are machined internally in the die, okay, in the solid block of metal. So they are always done like this, like what you see over here. Okay, so they are always done like this. So where you drill from one side, 2 or 3 sides, and ensure that the holes connect internally, and plug the holes later on 1 or 2 sides to make a channel the way you want. Okay, right. Yeah, so let's say you have, so this is quite interesting. It's a very simple example, but this is one of the very crucial problems that is very easy to overlook, and it's uh, it's not very easy to think about unless you have done some prototypes and all that. So let's say you have a piece where you want to machine this kind of a channel in a milling machine. So you have to clamp this, no, you have to hold this. Clamping on a round or a cylindrical surface is quite difficult, okay, and because even the slightest amount of misbalance in the clamping forces, it may misalign the part, and you will get a wrong machined surface. So it's always a good idea to design some places where you think the machinist will hold the part. Okay, it needs a significant amount of experience in designing machine parts to have a very clear understanding of where this should be there. But yeah, this is something for you to know about. Okay, and when later on in probably in some of the assignments, if I give you like a design to analyze, right, so how it was made using machining, then you can think about these kind of things. Okay, right. This one, the last one, I'm not too sure why it's there, because I think it's definitely possible to get this kind of rounded fillets. Okay, uh, so it says it's very difficult to get this if it's not entirely CNC machine. But nowadays with things like routers and all that, like handheld routers and all that, it's fairly possible. And you could design a jig, like for example, let's say you want a very round fillet here, okay? And this is made out of a softer material, let's say aluminium. So what you would do is you would first try to make two fillets out of, let's say, some harder material, let's say steel, right? And you would clamp it on both sides, and you can very easily make multiple parts with the same kind of fillets just by kind of grinding it. So it is possible to do something like this, but yeah, they're right. I mean, you need a precision machine to do something like this, and CNCs are the most kind of precision machines. Okay, right. Okay. uh what else? Longer parts are difficult to make. Typically longer parts, you should always try to see how much you can cut it, and you can ensure that rather than having a single part which is very long, you can have it made in 2 or 3 parts joined together. Okay, so that's an idea. And yeah, so this image is fairly interesting. What it says, let me just move myself on the other side. Right, okay. So in this image, what it shows is you want to make this kind of a shape where, let's say, on this part there is thread. So this is, let's say, it's a nut. Okay, it's a bolt. Okay, it's a special type of bolt which you need to machine for a specific purpose. So rather than doing, so you have to consider which stock or raw material you will start from. So by stock, I mean, like, let's say you can either choose to have a round stock, a cylindrical rod on which you'll do a lot of machining operations, like you could turn all of these surfaces, right, and then you can clamp it on this side and mill all of these surfaces. Okay, so yeah, that is a possibility, but think about the number of steps that's there. Rather than that, what you could do is you could directly take a hexagonal stock. Okay, you could cut it in length, and you could just put it through the lathe operation. Okay, you can just turn from a hex bar. Okay, so this kind of highlights the point that I made earlier. Try to avoid machining steps as much as possible. Okay, so if it's possible to just take the raw material in its actual form, take that. Okay, so here that's what the philosophy is kind of employed. So this is already there in the stock part, in the stock, material, and then the machining operations are only like one step, and you can do it in a single step, right? For example, you clamp it on this hexagonal portion and you can turn the remaining parts. Okay, right. Okay, let me just shift myself to the other direction. And yeah, okay. So I think we saw this very quickly. Okay, these are the different types of machining processes that are there. Okay, they are cutting and all that. All of these are different kind of machining processes. And so here, for example, facing is a machining process which uses the lathe machine, right? So most commonly used machine is a lathe machine. So in a lathe, you would put the cylindrical stock and you would remove a certain piece from the to create a flat face. Okay, so that is the process. But it could also be done in another type of a machine, which is the boring machine. A boring machine is used to make large holes. Okay, so it is possible. So it's not like a certain design. So the design that you are making, it's not like it can be made in just a single way. Okay, a machinist with significant amount of experience would be able to tell you the different ways in which you could approach manufacturing or machining this kind of a part. Okay, and that is what is being highlighted in this chart. Let's say broaching is a way of using such a tool. We already spoke about this, and you use a broaching machine. Sawing, you could use a cut-off saw or a contour saw, things like that. Okay, so these are the different types of machining operations. And yeah, so this list is there for you. I'll not explain this anymore, and we'll go forward to some advanced machining. So we spoke about this, some of these, not all of these. Let's say abrasion ones we did not speak about, but okay, we can just go with just like one line or two line explanation. Polishing is basically to make a surface smooth, right? Make a surface mirror finish. Buffing is like I shouldn't say an advanced form of polishing, but it's something like polishing where so if polishing makes the surface smooth, then buffing makes the surface mirror like. So it uses a special tool which is like made out of fabrics. Okay, a special type of abrasive fabrics, and you can press your tool against it and it will kind of remove very little material, and it's like polishing a surface with rough rough cloth for a very long time. Okay, it will get like this very shiny and smooth finish. Lapping, if you are into something like modding computer parts or something like that, then you already know what lapping is. Lapping is basically you have two surfaces between which you put some abrasive material and you rub the surfaces together. Okay, and you can get like a very flat surface from this. So in fact, if you have two surfaces which you definitely know are not flat, then using lapping you can make both of these two perfectly flat to each other. Okay, grinding, you already know it's an abrasive disc on which you which rotates and on which you press the part and it removes material. Yeah, well, these are like kind of okay. So honing is I think I missed this. I'm not sure what these two are. I'll come back to this later. Okay, let's go to these other processes. So the first one, non-traditional processes of manufacturing, machining. Okay, so there are two distinct categories according to this chart. The first one is abrasion based. So that means you use an abrasive material to kind of cut through something. So what you do is you let's say in abrasive jet machining, you have very fine particles of abrasives which you blast onto a surface, and that abrasive kind of removes very little material over the process, and it cuts through that. Okay. Similarly, water jet machining is also similar to abrasive jet machining, where but in water jet, what is done is abrasives are mixed with water. Okay, so we'll go through each one of these or some of these, and you can understand how it's done. So let's take a look at this one. It's called ultrasonic machining. Let's say this is the workpiece, and what you want is you want to have a certain impression on the surface, and it's not like a simple impression which can be made by either a milling machine or something like it. It's fairly small, it's difficult to mill, and it has some of these like weird contours and cross sections. Okay, and so this one is showing like a cross section, but imagine like what you want is a very tiny square, perfectly square kind of cavity in that. Okay, so what you can use is ultrasonic machining, and the idea is that, so this is the tool, and the tool vibrates at ultrasonic frequencies, and you have a very fine spray of abrasives which touches the which is shot between the surfaces of the tool and the workpiece. So what happens is that, imagine like at a microscopic view, this is the ultrasonic tool, and it's coming down, and in between there's like some amount of abrasive material which is put in at every cycle. So when it presses, some material from this end is removed, and that the part that is removed is the negative of the shape of the tool. So that's the idea of ultrasonic machining. Okay. Electrochemical machining, I'm sure you know about the galvanic cell. Okay, and this is like a similar this is almost the exact process, right? So you have like an electrolyte, and you have the workpiece which is made into an anode, and the tool is the cathode, where which is designed in a certain way, which is designed to cut. Okay, so as you can see here, you have the electrolyte flowing in between the tool and the workpiece, and there's some amount of electrochemical discharge which happens in between these two surfaces, and the material is removed like that, and the material is washed away. The chips or the remaining material is washed away in the electrolyte itself. Okay, and so as you can see here, I mean, I don't know if you can see, but the tool will never have like forces on it. So apart from, let's say, whatever the pump and the fluids are being pushed into that, apart from the pressure of that, there's no force of cutting the material, because that's not the principle. Is not to cut the workpiece, cut and remove the material from the workpiece. Okay, the principles is electrochemical, using like an electrochemical process to remove material. So there's no forces on the tool itself. So this because of this, you can make like very intricate cuts with very sharp turns and all that, and the tool will not have any problems. It will not break and all that, unlike traditional machining. Okay, abrasive water jet machining is like a meme in the internet, so I don't know if there's a point in explaining what exactly or what it can do, but this is like the schematic diagram of what water jet machining machine looks like. So there's generally like a sapphire based nozzle, or a nozzle made out of some form of ceramics. Okay, and it sends in a jet of water mixed with abrasives, and this pump kind of sends in the water, and it cuts the material. So these are some outcomes of the water jet process, right? Okay. And yeah, so this is electrode discharge machining. The idea is that between this tool, so this is the tool, and it will be of the shape uh, whose impression you would want on the workpiece. So what you would do is you would so so generally it is done in a tank where the workpiece is completely submerged in a dielectric, so that the there's the so that there's no sparks flying out, I guess, right? So the way it works is that there's like a huge voltage difference between these two, and there's a spark which is created between the tool and the workpiece, and this spark kind of erodes away the workpiece, and because of which the impression of the impression of the EDM tool comes onto the surface. So that's how this kind of works. Okay, so these are just like one page slides of what this is, right? And what you can do from your own side is okay, so this is not really an assignment, but it's something that you can do to learn by yourself. What I want you to do is find out really good videos of each of these processes. Okay, and like let's say laser beam machining or something like that, and find out some very interesting videos and paste it on that OneNote collaboration space or someplace, right? I think I made some extra spaces for you to put these kind of things also. Okay, so yeah, so laser beam machining, lasers very powerful, they can cut through material, so that's the idea. So it's fairly simple. It's a very high energy laser which kind of melts the workpiece and cuts through it. Okay, and finally there are like I think this is the last one. Yeah, so this is the last one that is there in the slides. There are others, many other special type of manufacturing processes, and you can find these on the internet. Okay, and right, so this one is plasma arc machining, and the idea is that you make like a zone of very hot plasma, and that kind of melts away and cuts the material. And it's not a very accurate, or I shouldn't say it's not very accurate, but the space of cutting is fairly large. Okay, and there's a similar process in welding also, which is called plasma arc welding, which uses the exactly same principle, but the arc here is of slightly lower temperature, so that it does not cut through, but it melts the material and makes a pool where the molten material kind of merges with each other, and there's like a weld bead that is created. Okay, so these two are processes that you should know about. Okay, and yeah, I before we go into that, and let's just see the chat boxes. And Gaurav has a question: how is precision ensured by using something like liquid ECM? I think you're asking about EDM, like liquid electrochemical machining. Okay, yeah, let's go to that slide then. Right, so here the image that is shown is fairly very large. Okay, so this is just for instructional purposes. Okay, it's to show you the schematic of the whole thing, but in actuality the tool is quite small. Okay, it can be of something like several millimeters also. Okay, and what you would do is so yeah, so this works almost at a fairly counterintuitively high feed rates. Okay, so the tool goes in and it can cut through material just like butter, I should say, like very cliched way of saying it, but these tools it can be of any shape. It can be probably it can be thinner, and it can be of different shapes and all that. So here, don't get mistaken by the drawing. I mean, it's not necessary that the proportion of the workpiece and the tool needs to be so large. It doesn't need to be like this. Okay, I hope that answers your question. uh, and okay, so you are asking about whether how precise this is. See, it's it's very precise actually, and the way you could control the precision is by modifying the electrolyte, the voltages, and the tool shape. Okay, yeah, so that's how you can ensure its precision. And since it's like this electrochemical reaction, it's a domain which is very well studied, and the principles of it are very very clear. So you can modify some variables in it to get certain kind of outputs that you want. Okay, so that's the I think it's a little vague. My answer is a little vague, but yeah, I hope you get the gist of it. So if you still have doubts about it, then maybe Gaurav can take this up, find something related to ECM, and just enlighten the rest of the class. So that will be interesting. Okay, Gaurav, if you want, you can do that also. Okay. Okay, so let's go forward, and I think what I will do is I will introduce the assignment today, and we'll go into a little bit about the next section that we. Okay, so what we will do is I will initiate the assignment, and I will give you a brief tutorial of Fusion 360, because you will need you will need to learn Fusion 360 to do this assignment. Okay, that I am going to introduce. So let's go to the assignment. So this is the assignment. This is the module 2 assignment number 3. Should I call it assignment 3? Okay, it's okay. We'll call it assignment 3. M2A3. So this is M2A3. M1A1, M2A2 and M2A3 हो जाएगा. But it's okay. Or I should change it. Give me a second. Right. I think this one is more visible. Okay. Right. So this is M2A1, module 2, assignment 1. We will have a module 2, assignment 2 tomorrow, I think, or maybe on the third day. But yeah. So this is the first one. And the idea is that you are given a hexagonal cross section rod. Okay, the rod can be of any length, but the internal diameter of the rod, so this is a solid rod, hexagonal rod, the outer surface is like this. So this is the cross section. Okay, so the circle or the inscribed circle is 30 mm. Okay, so from this edge to this edge it's 30 mm, right? From all the edges to each other to the opposite edges 30 mm. The idea, what you have to do is to design a simple product which can be made using only this raw material and using only machining methods. Okay, so that's the premise of the assignment. So what constitutes a simple product, that is up to you. So simplicity is a relative term, but I will consider something simple enough if it has less than 12 parts. Okay, so I'm considering everything through screws, nuts, bolts included. So you have to make something out of this raw material. So this raw material is given to you. Okay, and you can use any machining method, or I should say any traditional machining methods. You can use some of these advanced machining methods or non-traditional machining methods, but do not rely on them too much. Okay, primarily the product needs to be made using traditional machining methods. Now you can use simple nuts, bolts, screws, washers, springs, etc. if needed, and I will show you a nice resource, online resource, from where you can get these things, okay, or the information or the dimensions of these kind of things, so you can use it, right? Um so you can't just directly model something and send me the model. That's not how the assignment works. So as a designer, you will need to have a process with you. So the idea is that you have to first make a set of ideation sketches. You have to make some varied ideas. Okay. So I don't want to put an idea into your head, but let's say you made one type of a product, and then another idea is another different type of a product, or another idea is a different type of a product, or it may be a variation of the same product, something like that. But you make a set of sketches with which you are satisfied with. Don't make one, and don't make 500. It's not necessary. uh, I'm expecting, let's say, minimum of 5 ideas. Okay, although I have not put in as a barrier, but let's say design somewhere around 5 ideas. More is definitely better, less is not very good. Okay, so by the way, when I say ideas, I don't mean 5 sketches. Okay, don't just make 5 sketches and done. Each idea needs to be explored with as many sketches as possible. So let's say I want to make a cup. Okay, don't make just one sketch of a cup. Okay, this is a cup and I will make out of it. No. So if you want to make a cup, make 10, 15, 20 different sketches of what this cup will look like. The cup is the idea, the sketches are to support the idea. Similarly, like that, I mean, make around 5 ideas. Okay, and you have to choose one which is a good design, which is you think it's very interesting and it can you can take it forward, and you have to model it using only Fusion 360. So this is like a restriction that I'm putting on you, and since I'm putting this restriction, I will kind of take you through a very bad crash course of Fusion 360. Okay, so in a few minutes time, and that will end this class today. And what you have to do is you have to submit the models and the renders of the product. So now Fusion 360 is an online cloud-based software, so you don't need to kind of download and upload the model. So what you can do is you can just share the model with my email ID. So my email ID, the institute email ID, is already has a Fusion or Autodesk account, so you can just share it to that. I think I can see it. Otherwise, you can save the model as F3D model. I think Fusion 360 has an its own soft file type, so you can save it as F3D and you can upload it into the folder. And I mean, you should at least make one render of the product, but definitely make several. Okay, and maybe take help of somebody like Cyril to understand how to make a render look good or something like that, that you probably he can answer. Okay, so again, remember to do this assignment in a way that it adds to your portfolio. Don't just do it for submission purposes. Okay, so add to your portfolio through this assignment. Okay, so okay, let me just, I want to show you. So let's jump into Fusion 360 and I will show you some tricks, or I will give you like a very basic crash course. So first of all, Fusion 360 is a free software for students and educational purposes, so fantastic thing. And the second thing is that it's a completely cloud-based software. It's very low size. When you download it, it's probably 130 MB or something, So you can just download it, install it in your computer, and whatever intensive calculation based things are there, that happens in the cloud. Although we will not do it in this, we'll just look at the modeling part. Okay, so when you first open Fusion 360 and you will have one panel like this on the side. Okay, so first of all, on the chat box, just tell me if you can see the screen, Fusion 360 screen, and you are able to follow through, because I'll have to hide the chat boxes and all that. Okay, so just do that. Till then, I'll just have a little water. Yeah, okay. Okay, thank you. So when you open Fusion 360, the first things that you will see is this panel on the right, and this is like a explorer. So what you will have is, so here let's say these are all projects, my things that are owned by me, things that are shared with me. So these are some things which are shared with me. So right now there's nothing except for some sample data for learning Fusion 360 from Autodesk itself. So when you share with me, probably it will show up here. Okay, so so here I will open one of my earlier, let's say some things that I've made earlier, and I will, let me just open this. Okay, so all of these files are saved on the cloud, and Fusion needs a regular internet connection, so please ensure that. I mean, okay, so this is a design that I made earlier, just like a time pass kind of thing. So I'll show you some of the basic of navigation first of all. Okay, so I can close this from over here, and what I can do is I can uh, I can see the model. So here on the let's see the screen first. So first you will see that this top surface, here some commands are there, and on this side there's a big button which says design. Okay, if you press this drop down, you can see these are different workspaces, and right now we will be concerned with the design workspace, which will have all the tools necessary to model a certain design. Okay, so we will work with this only, but there are other also, like generative design, which is a way to model something using a generative process. Okay, so you can explore that as you learn Fusion a little more. Then there's a render workspace. Of course, you can render your files directly over here. It's not as great as, let's say, Keyshot or Blender in terms of rendering. You can do all the renderings here itself, but if you want to make better quality images, then you should shift to either Blender or something like Keyshot. Keyshot is paid, so yeah, Blender, I would suggest, it's an interesting platform. Okay, although there's a learning curve, and yeah, so you can restrict to Fusion itself if you don't know the other softwares. Then there's an animation workspace where you can show how things are disassembled and all that. There's simulation workspace, which is like engineering, understanding the whether the part has the necessary strength for its purposes. There's a manufacturing workspace, which is primarily related to CNC machining and all that. So it's a CAM workspace, computer aided manufacturing workspace. And then there's a drawing workspace where you can create the engineering drawings from the model that you make. Okay, so everything is here itself, so that's why it's a very, very versatile software. So let's take a look at the design which we will be concerned with here. So when you first open this, you will see like this. You won't see anything here. So this is a new file, so you won't see anything here. Okay, so files are opened on tabs on the top. So this one I just opened. This is the first one that I started with. So when you first open, you will have a folder structure and you will not see anything here other than these few things. Okay, so these are the views. So imagine these as like a folder, okay, where specific information is stored, and as and when you start modeling, this will get populated on one side, okay, which you can see over here. Okay, so what I can see now that I've kind of done this model, I can see that there are origins, there are some form of joints. We will not go into this a little in this lecture. There are some sketches and there are components like this, right? So you can select each one of them and you can see, okay, what this is, what is this, and what is this. So this one is this rod component, this one is this small component over here, this one is this one, and so on, right? And at the bottom, this is the most interesting and probably the strongest part of Fusion, which is parametric modeling. So parametric modeling is basically something like this. So let's say this is like a timeline. So what happens is, as soon as I do any modification to this model, which changes the model, that information is recorded and I can kind of go back in this timeline. So I hope you can see my mouse, this purple mouse, and I can go back. So I can actually go all the way back to when I started this model. So I can just, right? So I can click these buttons to go, and now as you can see, there is nothing here, right? And it is showing me that I have not saved it and all that. So I can go one by one. So I made a sketch, okay, and this new folder has come alive, and this is the sketch that I have made, and I have done some operations like this, and slowly I have built the model. Okay, so yeah, so this is how this is kind of a timeline, but it's not exactly a timeline. So what this is a stack of um, operations that have happened one on top of the other, okay, and you can access this stack of operation. Here it's laid out like this. So this is let's call it a horizontal stack. You can access this stack and probably modify one portion, remove one portion and modify it. So let's just say this one here. So this is a part in the stack where I have modified. When I click it, it shows me where is that modification. Let's choose one which is fairly obvious. Okay, so I want to choose, let me choose this one. Okay, so I can go and I can right click on this part and I can edit feature, and it will jump back to that position exactly how it was when I had earlier modeled it, and I can kind of change the particulars of this. Let's say I want now a taper. I have designed it, but I am not happy with the whole thing. I need a slight taper at one end and so on. I can give some angle and I can make that necessary. I'll not change it because so the reason I'll not change it, okay, let me just change it. So I'll give a taper of 30 or right 4. Okay, this is what happens, and I'll do an okay. So it will update the rest of the model, and as you can see, there are errors which are creeping up because because as the new things are added, these newer parts. So let's say this action that I had done in this part of the timeline was based on the prior action that I did over here. Okay, so that's why there are some errors which are creeping up, but you have to appreciate the fact that I can go to any part of the design and very specifically changed a certain dimension or a certain way in which it was made. Okay, so that is the power of parametric modeling. This is not available in something like, let's say, Maya or Blender, which is not like a parametric modeling software. Okay, so and then on top of that, if you had noticed, the way I edited it, I gave us very specific number. Okay, so 4 degree, and I can be rest assured that whatever taper is being happening is exactly 4 degrees. I don't need to go there and fiddle with my hands and do a manual adjustment to make it somewhere close to 4 degree. No, I have given like a proper dimension, and this mathematically calculates whatever is necessary to give me the result, right? So let me go back to the 0 degree and let me press OK and see if the errors are cleared. Yeah, see, as you can see, all the errors are cleared. Okay, so this is the idea of parametric modeling software. Okay, so now let me just tell you how to move around here. So what you can do is, if you middle press on outside the model, so let's say this is the model, you can click anywhere and select which part this is. If you middle press and you move, it'll rotate and it'll orbit like this. Okay, and as you can see, the box on the top, so it'll be somewhere here on top, right there, it moves around. So now you are looking at it from the front, and I can look at it from the top, I can look at it from the left, and so on. Or another way I can do is, I can just click on the front and I can click on these arrows, and yeah, so this helps in moving around the model when you are doing the design. Okay, and there are other things also, like for example, if you want to just move in a single plane, you can press Control and the same middle mouse button and click around and move around, and it will move in that, it will pan. Okay, if you press Shift and move the Shift and middle mouse button, you can zoom in and zoom out, okay, by moving the mouse up and down. Okay, and I don't think Alt is there. Yeah, Alt is also there, but it's not used as much. So the mostly it is what I do is, I use the middle mouse button and I can scroll in to zoom in. Okay, so I can scroll into this level, and I can, when I model, I do it like this. So I want to just put a fillet over here, so I can select this tool and it will show me a tooltip what exactly this tool does. I can click on it, and let's say I select this part, and I can, what happens is, I get this kind of a place where I can put the dimension. I can put 2 mm and see, okay, it will not give 2 mm. What about 0.5 mm? I can't make, I can make a 0.5. So now it's made a fillet out of 0.5 mm. So as you can see, it's a very dimension driven modeling software. Okay, I can just click OK, and now the fillet is there. Right. So let me go back to a blank canvas. Okay, so this is a blank canvas, and now when I start modeling, how I should start. Okay, so let's say I will do this only. Let me make first the raw material. Okay, so the way you start modeling is, the fundamental principle of modeling in Fusion 360 is, you make a sketch, and on a flat plane you make a sketch and you extrude it. Okay, that's like the very basic of modeling. Okay, so how do you make a sketch? There's this button right here which says create sketch. Okay, it will give you a tooltip when you hover over it. You click on it, and now the button is highlighted, and you see on the screen these 3 surfaces. So these are the origin planes. Okay, as you can see, if I go to the front view, I can see only one plane. The other 2 is this, here and here, right? So X axis is red, Y axis is green, and Z axis is blue. So let me select, let's say, one of them. Let me select this side plane. Okay, and I want to sketch on this. So now as soon as I selected the side plane, things changed, right? on top there are new tools which are there, and there's a palette which kind of formed in came up from the side. So what you would do is you can select one of these and make a sketch. Let me make a circle. So this is a circle, and I'll click a point and I'll drag the circle, and I can, so if let me just do that again. Control Z goes back, click a circle. When I drag it, I can see that there's a dimension that is showing up, right? So I can leave the click. Sorry, once again, I can leave the click, and my hands are not on the mouse, but I can, if I move the mouse, it is still there. I can just type in the dimension. So what was our dimension of the raw material, which is 30 mm inscribed, okay? So 30. Okay, since my units are set up to be in millimeter, this is given me a 30 mm. Otherwise, to be sure, I will do mm and do this. Okay, so now you can see the circle is black and this dimension is created. You can move around this by clicking, but we wanted a hexagonal rod, not this, right? So okay, so what we can do is we can make this like a geometry which we will use just as reference. It's a construction geometry. So I will click on this, and you see this palette. There are these various options over here. One of them is this construction. Okay, if I click on this, it will become a dotted line, and the shortcut for this is X. Okay, right now don't rely on shortcuts because you will be new. So just follow the buttons on the screen. You can do all the work in Fusion with one hand only. Okay, with this mouse. Right, so this is a construction geometry, and now let me find hexagon. So I can go into this create tab, and I can kind of find a polygon, and it says inscribe polygon, circumscribe polygon, and so on, right? Or there's a very nice shortcut. Now this one is an interesting shortcut. You can press S and a small pop-up comes up with a search bar. Okay, and you can kind of search for polygon and it will come up over here. And when you see this, when you hover over it, you get the small arrow. So what you can do is, let's say this particular tool is not available in this shortcut menu, so I can just click this button over here and it will come up over here. Okay, so that's an interesting way of making your own shortcuts. You'll need some tools which you frequently use. You can just add it to your shortcuts, your own. So whenever you need, you just press S, it comes up, and you select whichever is required and you make the thing. Okay, so we don't want this. What we want is circumscribe polygon, right? So we want something like this. Okay, so as you can see, this is the polygon, and the difference between this, let me just not make it construction first. The circle is, let's say, is black, and this one is blue. The reason for that is that this is a technical term here, let's say in Fusion, is this one is not a fully defined sketch. That means it still has dimensions which are not fixed. Okay, so the length of the edge is not fixed. Hence, if I click on the edge and drag it, then it can modify that length, and Fusion can modify the length, and I can change that. So let's say I want to give a dimension to this. The way I do that is by this small tool here. So I click this, or I can press I can press D as the shortcut, and it will give me this tool. So I select this and I can give this dimension. Okay, so let's say 30. Okay, but this is not what we really wanted. This is just for example. Now also, however, So once I selected the dimension, it is still, so if you see my cursor, it is changed to this dimension arrow. I'm still in that dimension, uh, uh, tool. So what I can do is I can press escape and I'll come back to the main cursor, but still uh, it's not black yet. It's not fully defined. Why? Because, I can move it, I can rotate it. So that's why. So it's always a good idea to fully define your sketches before you move on. So most of the modeling that you do in parametric softwares like this is like you will make a sketch and you will move it. So the idea now that I have is I will make the sketch and I will extrude it. Okay, so let me quickly do that now. I'll remove this dimension and I will give the dimension which is here. Okay, this is 30. Okay, I can do this here, but still it's not fully defined. Okay, so rather than this, I don't want to do this. Okay, let me give you another way, very interesting way. So instead of doing this, what I want to do is I want to make this line tangent to this line. Okay, if you see this other section that's there on the top with the red icons, these are constraints. Okay, and these provide constraints to the, let me just check the chat box. Wait, what is happening? I didn't see so much of the chat. I'm seeing it right now. Let me just see the chat. Wait. Okay. 5 minutes break from Fusion. Let to just check the chat and reply to all of you. Right. So you can't see the drop down box. Can you not see the drop down box? Okay. I'm sorry. Oh my son. I'm sorry. I should have had the whole thing. None of the pop-up windows are visible. Okay. I'm sorry for the whole mess up. What is happening exactly? Okay, let me just do this. And let me move it here. And okay, give me some time to do a little bit of right. Okay, you can't see this. That's very strange, yeah. Okay, I don't know why this is happening, by the way. Okay, in that case, just give me a second. Give me a second. I'm so sorry. I missed the. I should have checked the chat a little earlier. Okay. Can you see it? Where's my chat box? Yeah. Can you see the things now? Oh my god, I'm so sorry. Yeah, I've been rambling without. Okay, most of the things I hope are clear because once you will install the whole thing, yeah, finally, I'm sorry about that. Okay, let me just. Let me just. Sir, we cannot see the browser. Yeah. They just, you're right. Alert button should be there. Okay. Is it better now? Is it better now? Yeah, visible now. Goodness. Anyway, इतना देर तक जो बोला, just rewind the whole video and watch it again, I guess. But yeah, okay. So let's go forward. Okay. So this was the drop down list that I was talking about. So you have design, render, animation, manufacture, drawing, and when you click this drop down, you will see all of this. Okay, and when you click this drop down, you will see all of this, right, and so on. Okay, so till now I'm making a sketch. That's it. You've not missed much. Yeah. Okay. So let's do one thing. So the idea here that I was going for is, I was going to tell you about these things called constraints. Okay, and I lost my train of thought. Okay, yeah, okay. So what I want to do is, I want to make this tangent to this. The way I do this is by selecting this, and if you see on top, some of these options are highlighted. So you can select this. This is called the tangent, and it will put a constraint between these two parts of the sketch to a tangential one. So let's click on this, and it snaps to that. So now the edges of the polygon and the circle is tangential. Like this, there are several other constraints. We will not go through that, all of them. But the sketch is not fixed. So what I will do is, I will give a horizontal or a vertical constraint to one of these edges. So what I will do is, I'll take one of the same edge, let's say, let's put it over here. Okay, and I'll say this one is horizontal. The first of the constraints, horizontal. So I will click on this, and that's it. Now I have two sketches. One of them is a construction sketch. So let's make that construction sketch here. Okay, and now I have the sketch. So I can still move around the canvas and see what I have sketched. Okay. Right. Okay, so once I've done the sketching, so now what I can what I have thought is on the screen. So I made a hexagon, and I want to move it, I want to extrude it into a solid shape. Okay, so what I will do is, I'll say finish sketch. This button here and this button here is the same. So I'll say finish sketch. As soon as I press this, the first parametric step is recorded in the timeline. Okay, and now this, I am in the 3D space. The top surface has changed. The tools which are relevant to modeling have come forth back again. Okay, so here you can see solid, surface, sheet metal, and tools. No, rather you just stick with solid, and you will make most of your models here. Okay, so what I can do is, I can click on this, and I can select this, which is extrude, and now there are two things that pop up. There's this small circle and this arrow. First the arrow. Okay, I can click on the arrow, and I can pull, and I've made like a hexagonal bar. Okay, and this one is so as you can see, the dimensions to which it is extruded is visible. Okay, so what I can do is, I can give like a dimension that I want to start working with. So let's say I want to give 120 mm. Okay, so it restricts to that, and I click enter, and this is the solid which is created. Let's go back and edit this a little bit more and see what that other tool was. So this one is for the angle. So if I click on this and rotate, it will give me the angle. Okay, it will give me a taper. So all of this is also updated in this small list over here. So I can modify this. Okay, so I can give, let's say, -2° angle. Okay, and I have something like this. Now there are these other small options also which come in very, very handy. So first one is that is where do you want the extrude to start? Do you want it on the profile plane? Do you want it offset from the plane? So let's say I've sketched it over here, but I want the extrusions to start from here. Do you want it from the object? Okay, so don't click object right now. Let's just keep it. Let's test with the offset plane. As soon as I do that, another option appears, and let's say I put 20 over here. So the extrusion actually starts 20 mm after the sketch is created, from the plane where the sketch is created. Remember, in Fusion, most of the work that you will do is by sketching on a plane. So find a plane where you can sketch, make a sketch, extrude from there, or cut from it. Okay, so very simple, something like that. This option is also very interesting, whether you want the extrusion to happen just in one direction, or you want it on both sides, or you want it symmetric on the both sides. So let's do two sides. So now the other side also comes up, and I can extrude on the other side. Okay, the same option, side 2, let me put it 100 mm over here and 7 degree over here. Okay, so you see this? So this is the shape that I've created. Or I can put symmetric, and it'll take, just copy the same settings that I've put on one side to the other side. So okay, this is like the very basic of the extrude command. You can make simple objects using just these two commands. But as you start modeling, then you will. So Cyril asked, does the taper start from the plane or from the start of the extrusion? The taper starts from the, so in this case, the midpoint over here, the offset, the 20 mm, after the 20 mm, it starts from this. Okay, so I've done this. So let me just, okay, here there are other things also. You can just put whether you want the whole dimension, you want to give the whole dimension as 120 mm or one side as 20 mm. So these are some interesting options you can play around with. So I'm just making a random object, by the way. I have no goals with this. So I'll just make a random object to show you what is kind of possible, right? And the last one, which is kind of important, is new body, join, cut, intersect, new body. Okay. As you move forward, there will be another option which will be added in this list, which is a new component. Okay, that will come in slightly later. We will take a look at a model, a different model, and we will see how the modeling was done in that. Okay, I'll click OK. So this is the model that I created. The extrusion is done. Now the sketch kind of vanishes. If you see over here, there's this small eye icon. If I click on that, I can see the sketch again. Okay, and I can reuse this sketch. So let's say I want to make another extrusion from the sketch itself. So I can click the sketch, I can click extrusion, and let's say I did something like this. Okay, but what I want is, so as you can see now, what is happening is that I've extruded, but it's not showing me in the same color, like gray color. It's showing me in this red. So what is happening is that it's actually cutting. The extrusion is also used to cut. So here the operation is cut. Fusion is intelligent enough to understand when you want to kind of cut or join. Okay, so if I put join, so it will show me that it is joined with the surface or the body that's underneath. So let me do a cut, and or I can do intersect also. So it will show me that this portion is that. So these are things that you will explore. You can learn by exploration. So I'll just cut. But what I want to do is, let's say I want to offset, and I want to do like 100 mm or minus 100 mm, right, on one side. And instead of cutting this way, I want to cut this way, and 30 mm, and I want to taper 15 degrees, or not like this but the other way, minus 15 degrees, and it's still creating this small edge which is very sharp. I don't want that, I want a lip. So let me just move it to another 15 mm. Okay, another one 20 mm. Okay, yeah, so I wanted this, and okay, right. So with the same sketch I made these two features. As you can see, as and when I add these new features, it will keep on updating the parametric list. Okay, right. So, and on the screen, you can see that this small tab is also updated, and it has a new body. So this is a new body that is created. Okay, so these are some of the jargons that are needed to understand the software. I mean, it's new, it's not common to all other software. So you use these jargons. I mean, you have to understand these jargons, what the software means, right? Okay, so now what do I want to say? Okay, so as I said, you can sketch. Now the modeling schema works like this: is you find a plane, find a surface which is flat, sketch on it, extrude from it, or let's say do some other operation. So I found a surface which is flat, I want to sketch on it, and let's say this time I will make like I'll make a text, and I will make something like 203. Okay, and I made this, and I finished this. Okay, sketch is done, and I'll extrude. Okay, yeah, okay. On this side, I want a sketch of a slot. So I'll take a slot from here, click here, and it's not fully defined. So if you right click, you get this kind of a pie menu with some of the common commands. You just go to that direction, and you can be very fast. Actually, you can be just like this. Okay, anyway, so it's still blue because I can move it. So let me just put some constraints. I want this to be horizontal. Okay, and I want, or I don't want that, I want this to be parallel to the surface. So but that is not there, right? So what I can do is I can make like a construction geometry. So I'll take center point here, and I'll find another. So let me just, yeah, I wanted that. So first, I'm in the sketch tool. So there are some things that I clicked that I didn't explain. Like for example, this one is a look at command. So if I select a plane, and if I say look at, it will make it perpendicular, make my view perpendicular to that plane. It's very it's very easy to shift the views. No, when you are sketching, you need to go to a perpendicular plane, right? So I can do it like this, or I can do it like this, right? Okay, so now let's say, where was my sketch? Where is my sketch? Okay, so I want to create a line that's from one point to the other point, right? So this is, I'm sure, since the model is made in a certain way, I know this line is certainly parallel to the axis of the model. Okay, albeit in this plane. So I made this as a construction line, and I pressed S to come up with this shortcut menu, clicked on this, and made a slot. I want to make a slot over there. Okay, so this is still blue because it's not fully defined. So what I want to do is I'll put dimensions. So I'll either click on this, or here I put S, find this dimension, and let's start adding dimensions. I want this and this to be 10 millimeters apart, this point and this point to be 15 millimeters apart. Okay, I want this circle diameter to be, or radius to be 3 mm. Okay, and now as soon as I put that, this has become black. Now my cursor is still in a dimension setting. I'll press escape and go to the main cursor, and now I can't move it. It's black. That means it's fully constrained. I'll finish my sketch, and this is what I have. I'll click on this surface, which is the internal space of the slot. Click on extrude, and I can cut it inside. Okay, I can put a perfect dimension over here, let's say 7 mm, and I'll put a small taper of -1 degree. Okay, just to make it interesting. Okay, this is a slot that I cut. Okay, next I want to show you how to make standardized holes. Okay, so that's very important. So again, let's take up another surface to sketch on. Let's take up this surface to sketch on. I click on the surface, and if it allows me to sketch on it, that means it's a flat surface. Otherwise, it's not a flat surface. Again, let's go through the same thing. Let's make a construction line so that it's easy for me to base the rest of my drawings in on that line. So I made this line, selected it, made it construction, and let's say I want holes along 2 or 3 points here. So I can do like a point. Okay, let's do a point. So if I go into this menu, I have a point here. So I'll click this point and let me make some points. Let me make 3 screw holes here. See, whenever my cursor snaps to a position and shows me like a triangle, that means it's the midpoint of that particular edge that I am on. So this is the midpoint of that line that I created. And then let me make one more here. And now I press OK, and again I press S to come up with this shortcut menu where I've kept the dimension shortcut. So I click on this and click on 2 places, reference places where I can put the dimension, the point and this line, right? So this point is, let's say 15 mm or 20 mm from the, let's put it on 25 mm from this line. Okay, and this point is already in the middle, so it will be fixed. Let's put this from this edge at 25 mm. Okay, fantastic. I have 3 points and I want holes at each of these 3 points. I'll finish this sketch, and now if you see here on top, there is a place, there's a command for making a hole. Now if you click on this, it will give you this panel where it will give you the exact hole type. So do you want like a simple hole? Do you want a counter bored hole? Okay, do you want a counter sunk hole? Do you want a tap? That means do you want a screw thread like this, or do you want a tapered tap, and so on? Do you want a clearance hole, and so on? Okay, so which type of drill point do you want? So it is giving you the option of both types. You want flat drill or so this can be done with an end mill, but it's not a good idea. But you can do like a normal drill also. So I want to select like a counter bored hole just to show you. And what I can do is, if I just now on top it says placements. Where do I want to place these holes? Do I want to place it at a single at a point, or from a sketch, from okay, from a sketch? So in this case it's from a sketch, so I'll just do this, and now my cursor, this part is highlighted, so that means my cursor is ready to select the places where these holes need to be. So I can select this, I can select this, and I can select this. As you can see, this is too large and it will kind of make a mess of the whole part. This is not what I wanted, but as soon as I selected these dimensions came to me, right? And I can now give like a proper dimension. It's now these are based on the screw dimensions of the standardized screws. So you can either, okay, you can either, you know, just give here, like let's say I want this as so this height, this is the height, So I want this as a through hole, completely through the body. So I'll give like a large dimension. Let's give like 25 mm. So it's gone through, it's not gone through this. So let's give more. Let's give like 50 mm. Okay, it's gone through. The diameter needs to be smaller, like 25 mm is too large, so I want like a 4 mm hole or a 5 mm hole, let's say 5 mm hole, right? And then this taper and all, it'll let it be in this way itself. This is kind of standard. This counter bore, I'll make it like 7 mm. Okay, so now you can see the depth that's cutting. This one definitely doesn't need to be 30. So if it's 5, I'll add plus 5, so let's say 10. Okay, and you can see I still think that the depth of cut here is a little too much. Let's do 5 mm itself, and I'll click OK. Okay, now I've created these holes where I can put in the screws necessary. Okay, yeah. So this is like the very basic of modeling. The rest of the things I want you to explore and find out, and I'll give you a good resource where you can kind of find these kind of modeling this thing. If you go to the YouTube channel, Product Design Essentials. Okay, let me just see if that's the name of the. Just give me a second. Yeah, the name of the channel is Product Design Online, and I'll just show you that. Yeah, so this is the name of this is the you know channel, and he has like he's a very good teacher, and he has so many different uh, tutorials from very basic to quite advanced also. There's one which is absolute beginner. Okay, so this is a nice playlist for you to go through to understand Fusion 360, and this will help you to model the whole assignment. Okay, so I'll not let me just run through. So he'll tell you a lot of other things also, and yeah, so you can easily take whatever you model over here to uh, 3D printing and so on, right? So okay, so we are done with this part. You need to ask, if you have any questions you can ask me. I am terribly sorry for not checking up the chat for some time, but yeah, I hope that it still made sense, because I was doing most of the things which on the screen itself. Okay, as I said, let's see some of the models. So I want to show you a model. Okay, I want to show you this. Let me. So this one, this thing takes in what? So this one has some advanced parts to it, like there's some really advanced modeling methods, and this is like a pencil that I designed, and it has. Are there any animations here? No, there are no animations here. So it has these different parts, and it's like a fairly long modeling, parametric modeling stack. So as you can see, if I scroll in this part, so you can see it's like so many steps, right? So let's just go through some of this. So to create something like this, what you would have to do, right? So I started off with first making like a simple sketch, and this sketch is over here, as you can see. And can you see? Right? So this is the sketch, and I extruded that to make this cylinder. Okay. In the middle you can check the dimensions of the part by clicking on this button. This is the inspect button, and if you select an edge, it will give you some idea about what its dimensions are. So this is the 4 mm big diameter rod that I modeled. Okay, then I moved forward. Fayaz, you can't see anything, is it? Okay, you can see. Right, so next I model this, and let me show you. This is the sketch. I modeled this part, then I modeled this small sketch over here. I went to this surface and I sketched this, and extruded that. Now I have this kind of a part, right? Then I gave something called chamfer. So here, this, when you click on modify, you'll get this thing called chamfer. Chamfer is like a taper edge that you can put. Okay, so you click on this and you will give these chamfers and all. So I gave this chamfer here, this chamfer here, and like I think a small fillet on the bottom, just to create this. So my idea was that I'll put a thread over here, and on the other end I'll make this as the main barrel of the pencil. Okay, should get it in the center. Then I sketched another sketch. Where the hell is this? Right here, somewhere bottom. Right, so this one, this small sketch to make a hole, and then I made a hole with this. So this hole goes through and through till here. This is a blind hole. So all the while I'm kind of thinking whether this will be, yeah, a bevel. Cyril, right, bevel is like a chamfer. Okay, so this command over here, it can also be called as a bevel. Okay, so here I made this sketch, this small sketch over here, and I made a hole. Okay, the same command that I showed you. And again, I kept on making sketches. Now this one, where did it go? So if I can't see, I'll look at where. So I'll just hide the others. Right, so this one is on top. So on top I made this, and then I made another hole. What just happened? Right, so I think that hole I did not. So once I started modeling, I had to come back to certain previous positions, and what I did was I selected that, and instead of deleting it, okay, I did not want it, so instead of deleting it, I pressed something called suppress. So I click on it, there's something called suppress feature. So it will stop the effect of this step on the parametric stack. Okay, that's the idea. So this one is a suppressed feature. I don't want it. I didn't want it after I went a little forward, but instead of deleting it and not being able to roll back to something I have done previously, I just unsuppressed it. I clicked on this and pressed unsuppress, suppress. So here it's giving me the option to unsuppress. Okay, so let's move forward. Then I made another sketch, this one, right, and I extruded cut this part between those two circles. I gave some amount of taper over here and a thread over here. So this thread is again a command over here, right? You can find all of this here. You can just drop down and start exploring this. And now I have threads on two places, one place here and one place here. Okay, and it's like it's modeled. You can see like it's showing me as a thread over here. Okay, so all of this. So let me just try to edit this feature, and I'll show you what kind of options there are. There are these various options. What kind of thread do you want? You want an isometric. So international standard organization metric profile or something like that. Use ISO standard only. And what size? M10. I wanted an M10 and 1 mm, something like that. And all these, with this information, it modeled the threads. I kept on sketching. So this time around I sketched something like this. I extruded it to cut in the middle. Okay, so this is my idea, that you'll have like a saw which will cut through this piece, and there'll be a hole which will be done from here. So this will be in, you can entirely machine this, right? And then I sketched this small slot and I cut this also. Okay, so I'm getting to the body of my design, and slowly now at this point I said, okay, so now this is one part which is completed. I need another part which goes in. What I did after that was something called create a component. Okay, here when you go to assemble, create, when you go to create, you have an option to create new component. So with this, what happens is that something like this is added. Okay, this is, you can imagine this as a folder for certain types of parametric modeling, certain parametric modeling steps which belong to a different body altogether. So like this is one body. In this component I'll make another body. I'll show you, right? So I sketch something here on one of the faces on this plane. I made this sketch, but when I made this component, no, I selected this component and I started working on that component. So let's select this, and as soon as I select, the parametric, everything else vanishes. This model goes like a different goes into a different view, and I have this thing. So I'll just model a different object in this, right? A different component. So like this, I sketch, extrude, sketch, extrude, sketch, extrude, fillet, chamfer. Oh, sorry. Right. So I did so much, and I made a new part. So here I have another component. I have the main assembly. So I have the main body on which I have a new component. Okay. So now as I keep on modeling, I will add new and new features. I will add new components, and then I'll not go through all of this, but yeah. So you can get an idea that it's pretty straightforward to explain. So what I can do is, if you want, I can give you this model for you to explore, for you to understand how the modeling was done. You can rip apart this model, and you can, by rip apart means you can kind of try and understand how I have done all of these different things, and you can learn the software a little bit more. Okay, so this model I will give you. So with that, and with that product design online YouTube channel, you can learn Fusion 360 and you can do your assignments. So I want to stop over here. We have gone on for a very, very long time. Okay, and yeah, so I don't want to keep you waiting. Where's my OBS studio? Yeah. Okay. So let's see the participants. It's just Cyril. Thank you, Cyril, and thank you everyone who are there in the stream. I'm sure everybody else will look at the stream later on, and they'll see what needs to be done. Okay, so we'll stop here, and the recording will be up for you. Thank you so much, whoever was there at the beginning. Thank you so much. It went on for a long time. We'll catch up again same time, 3 o'clock tomorrow. Okay. See you guys.